Okay, so this is part 4. This will be the final part of the lecture. And like I said previously, I'm going to take you through a comparison between the series circuit and the parallel circuit. Now what I'm going to do is actually draw these up on this program, and I want you to watch me draw this simply because, I'm just going to reset all, because I want to show you how they're connected, because they are different. At the top here I'm going to make a series circuit. So remember, a series circuit is one that is completely in one loop. And I'm going to make this into parts so it's easy to see, like this, that I am making, one loop. And to save on space, I'm just going to take these light bulbs and just do one of those, turn them down like that, and do that. Put them inside. It doesn't matter that they're upside down. They'll be okay. They're made for this, right? So notice the way I'm connecting them. I'm making a loop. I'm going to put a switch in here. Now remember, a switch basically is a break in the circuit unless I, of course, close the switch. So if I close the switch, boom. And we can see a problem. Let's fix that. I got to make sure that my circuit actually connects. I think that worked now. There we go. Now let's keep these the same. So let's change the voltage to 25 volts. That's bright enough. Let's close the circuit. I'm going to show the values. These are 10 ohms each. The same resistance. And notice the series circuit has one loop. And what I can do is I can measure the current, ta-da, through this loop, 1.5 amps. Now actually what I'm going to do is, just remember that number, 1.5 amps. Is let's see what happens when I add another light bulb in series. Will the current increase or decrease? Ask the question in your head. So let's add another, light bulb with the same value, same 10 ohms. If you said decrease, you're correct. It was originally 1.25. Now it's 0.83. So what happens is, as you add more resistors, you're adding more resistance, which means you're slowing the circuit down. You have more stuff. Think of this as a crowded highway. It could be a hallway or highway. More cars on that highway, the harder it is to move through it, as you can see here. If I take this out, 1.25, much faster. So in a series circuit, we share the same current, and the resistance adds. So I'll say it again so you could write it down. In a series circuit, if you add another bulb, the resistance adds. So you increase the resistance, and then the current was about 1.25. I guess I won't, I suppose we can write in here. I could do 1.25 amps. I could just use my pen. I think I will do that. So this is for 10 ohms, 10 ohms. Let's use my pen. Let's do it from the slide. From the slide. There we go. And remember, oops, do it again. There we go. This is 10 ohms here. And this was 10 ohms here. And this battery was only one, but 25 volts. So let's compare. Let's see what happens when we do it in parallel with the same stuff. Remember, this is going to be the same, and we'll keep these all the same. Let's see what the current is. But the interesting part is, I hope you realize that there is going to be more than one current because there's more than one branch. There's a branch here where the charge can go down, and there's a branch here. So I have to take multiple current measurements, and technically through the battery. So the fact that there's one here is actually incorrect. But let's see. So let's make a parallel circuit. So set it up very much like I have it. This battery here. Use this. The mouse is actually much more sensitive. There we go. Now watch the way I'm connecting it. So notice I'm going to make a junction here, which is different from up there. There's no junctions there. But this has a junction, a place where the current breaks off into two parts. This is also a fun lab to do. I do with my AP students. Actually, and my CP students. All my students get to do this. So if you see here, I'm making the same circuit. Don't connect that. There we go. Okay, there we are. Cool. Let's change the voltage to 25. Whoa! Did you see that get brighter? It's so much brighter. So let's measure some current. So let's measure the current in this branch. That's way higher, 2.5, 1.5. So this is already double. Now these are the same resistance. Let me show value just to prove it. 10 ohms, it's hard to read. This is 2.5. This is 5. Whoa! We have so much current in this, so much more than this. But if you think about why, it's because the battery has now the, not the battery, I'm sorry, the charge has a choice. You could go down this one or this one. So half of them are only going down here and half of them are here. So they only see half the resistance because they only go through one bulb. So I would rather go through one bulb. So, and I hope you notice too, we won't go into too much calculation, but if you see 2.5, 2.5, 5, did you say that this plus this equals that? Because that's great, because you're right. So 2.5 plus 2.5 gives you 5 amps. So the current in is the same as the current out. That's the law of conservation of charge. That is so important when you solve this out. So, answering our questions, a parallel circuit is brighter than a series circuit. Parallel circuit does not have to share its resistance. It only sees one of the resistors. And what happens if I take out a bulb? Say it doesn't work anymore, right? This is what happens when you have Christmas lights. So let's say the bulb is out. They all go out, right? Well, that's annoying. That's a famous Christmas song, right? If one they go, you know, if one goes out, they all go out. The guy gets mad, right? So what happens here? If one goes out, it still works. You know how this is useful? In your house. Imagine your house is actually connected in parallel. Because imagine if you shut off your kitchen light and the whole house went out. That would be quite annoying. So your house is actually circuited in parallel, such that when you take out one or you close the switch of one, oops, you can see I shorted it. Sorry. Oh no, getting nervous. Let's remove. Split. There we go. Oops. It's very finicky, as you can see. There we go, on time. We're good. There you go. Put it back in there. So there you have it. Like I said, when you take one out, if you shut off like your, shut off the TV, the light in the living room is still on. So that's kind of a nice feature. So your Christmas lights are now strong like this. So not all of them go out, only half of them maybe, or usually it's like a third of them. But that's why, or that's the main difference between parallel and series. So let's take a look back here. So let me go back to the slideshow. Let's take a picture here. Perfect. So the current here was 2.5 amps. Current here was 2.5 amps. Current here was 5 amps. Each bulb has all this stuff. Which produces more current? The parallel. We could see that through the numbers. We see here, these are much larger than this number right here. Which circuit is brighter? Parallel. It's got more current, so it's going to have much more energy, just like that. So if you add one more lamp in series, what happens? The current decreases. We saw that. current decreases. The voltage stays the same. So if we put the voltmeter across it, we would find, well, let me be careful with that. If we measure the voltage, let's put this back in there. Swing this around. Oh, bummer. That was going to happen. Split. Very finicky. There we go. So let's measure the voltage now. So I'm going to do that with this voltmeter. This voltage here is 1250 between that bulb. The voltage here, 1250. What's the voltage of the battery? Do you remember? 25. Did you say that 1250 plus 1250 is 25? You're right. So as you add another bulb, you actually will reduce, split junction, the voltage. In fact, we add another bulb, watch what happens. Remember, our battery is 25. Now it's 8.33. 8.33. 8.33. Get out your calculator. 8.33 plus 8.33 plus 8.33. That equals 24.9. Or in other words, 25. So the voltage also, as you add more lamps, so lamps mean bulbs, they actually decrease too. But they add to the voltage of the battery. So battery. So the voltage of 1 plus voltage of 2, etc. You don't need to do any math, just understand this. And as you add more, it decreases. Like this. Oops. I didn't mean to do that. What about parallel? The current we saw, we add another bulb, we find that the current will reduce as well. So let's add another bulb. And then add another wire. Watch what happens if I add another bulb here. See if the brightness changes. Come on. Wire. You notice it doesn't actually change. Pretty crazy, huh? If we measure the current, it's our ammeter. Got a lot going on here. There we go. 2.5, 2.5, 2.5, 7. So the currents always add to the battery. Sorry, this is battery. So the current in each branch, I1 is one branch, I2 always add to the battery current. Now the voltage, I'm running out of time, oh no, it's going to be the same for each, which is pretty crazy. This would be some value, this would be the same value. That's because the voltage it sees is actually across the battery. So it's actually the battery voltage. I have 30 seconds, so the brightness stays the same. Pretty neat. So, parallel circuits are generally brighter than series circuits, and you have higher currents, which is how you can overload your circuit, which is why you can overload your circuit in your house. I'll have one more part 5, just to summarize